Hello there. So we're going to talk about getting the code onto the Arduino now. So I've just come to Google and I've searched Arduino IDE, and we're going to hit that first link. So arduino.cc is the address, and you come in here and select whichever download option suits your system. For most of you, it's going to be these Windows ones. It's a standard download. Click it, it appears in your downloads, run it, allow it to make the changes, and you'll get the Arduino IDE. So when you first get into the Arduino IDE, you're going to see something like this. Just let it load up. So this is your first sketch sort of thing. And what we're going to be doing in there is essentially deleting everything, which gives us our fresh IDE to work on. So I'm going to not save that one and show you the code that we're going to be implementing. So with this, we've got a few things that we can change. It's not massive code, but basically there's settings here that we can look at, and a couple of other settings that we might want to change as well. So first things first, start pos, mid pos, end pos. They're all of our positions. So the starting position for our movements is 0 degrees on the servo. That's why we plug our Arduino into the servo before we hook the servo horn up, because it will set the Arduino and it will set the servo to its 0 position, 0 degrees. From there, we've got our mid position. So this is 18. The mid position is what happens when you press it once for the uncoupling motion that occurs. The uncoupling motion, for me, I found that 18 degrees works really nicely. Might be different for you guys. You might want to use a different number here. And that's absolutely fine if that's the case. You can change it. If you find that your stock's becoming derailed, then maybe you want a smaller angle, so reduce this, start at maybe 10. If you aren't managing to uncouple, then get rid of 18 and maybe increase it to 20, 25. And then finally, the end position is 160 degrees by default. Now, not all servers are created equal. Some of them have slightly different sweep ranges to others, and that's where tweaking this comes in. So basically, we want our servo to move 180 degrees. So if I get a little box to represent our servo, there's our pivot point, and then we've got our arm that sticks off. So this is the position it should be in at 0 degrees. Now, sometimes if you move it 180 degrees, it will come around here and stop. It won't stop quite 180 degrees from where it started. So that's why I offer the opportunity to sort of change this. So 160 was what I found worked for my servo. For yours, it might be something different. You might need to tweak this a little bit. The other thing that we want to make sure isn't happening is that the servo isn't stalling. So if your servo is trying to rotate from 0 degrees here, and it can only get to here because, I don't know, say something's gotten in the way, a wire's got caught here or something, your servo will start to stall and burn out, and we don't want that to happen. It can also happen if you try and send it too far back. So if you're trying to send your servo, not that one. If you try and send your servo further back to this sort of angle and it's banging on the top of the tippler, you don't want that. It's going to burn your servo out. So that's why we have those variables. Your step delay is how quickly your servo will get to the position. If you want it to be more prototypical, increase this number. Just bear in mind though, the longer the gap that you put here, the more sort of the less smooth the movement will be. Now, other things that we can change: long press duration. So this is 2 seconds. The value 2000 here corresponds to 2 seconds. And if you want that to be less, so if you want to only hold the button for 1 second to initiate a full cycle, change this to 1000. Then your last one is going to be this delay here, the delay that's set to 3000. So this is the value that determines how long the wagon stays tippled for. So how long it pauses for at the end of the movement. If you want it to stay there longer, increase the number. If you want it to be less, decrease the number. Now, for this situation, what we want to be doing is uploading it to our Arduino. To do that, I'm going to get a USB-C cable. I'm going to plug it into my Arduino. And there we go. And you'll see up here, it's worked out. I've plugged an Arduino Nano into COM4. So you want to make sure that it says Arduino Nano and whatever port you're in. Chances are, if you've got nothing else plugged in, it's going to be right. Bear in mind, I've had issues where if I've got a wireless mouse dongle plugged into one of my USB ports, this can cause a few issues. But on the whole, pretty straightforward. Select the one on COM4. After you've done that, we want to press upload. And you'll see it says compiling sketch, and this will change to uploading, and then it'll say done uploading, and you'll see a few little outputs here that these are just confirming that what we want to happen has happened. If it comes up with some horrible red writing, it means there's something gone wrong. So for example, if I do something like this, try and upload it. Oh, this one has worked. That's good. Just let's see if it uploads now. So you see how this is taking much longer to upload because I've changed that. What we want is the upload should take a few seconds. You know, we've already been waiting far too long. So I'm going to cancel that. If you're getting that issue where the uploader is taking ages and you'll get a bunch of red text down here saying it can't do it, you're going to go to processor and select Atmega 328p old bootloader. And that, once you press it, compiles the sketch. So that's probably taking about 8 seconds, and then it uploads it. And you see how quick it was compared. Now our Arduino is set to go. Once you've done that, make sure you disconnect your Arduino properly. At the moment, I don't have it on here, so that's fine. Yeah, so I'm just going to yank the cable on mine. Once I've unplugged it, you will, or I can plug the USB cable into just a power port, like a phone charger, and the code will run when I press the button. It does not have to be from a computer. It doesn't have to be USB from a computer. The only time you need it connected to the computer is when you first upload the code. After that, unplug it, plug it into a little phone USB port, and you're good to go. It supplies power. If you have any questions about any of this, you want talking through any of it, I'm more than happy to. Just give me a shout, and I will help in whatever way I can. Thank you very much.